Please open in your learning workbook to page 131. We're going to solve some problems where your job is to identify the value of a, h, and k for the parabola equation provided. All right, here's the first two. H of x equals negative 3, parenthesis, x minus 4, close parenthesis, squared, minus 2. All right, so here's what we need to remember about this. A is the number multiplying by the squared part. H is the number inside the parentheses being subtracted. K is the number being added or subtracted outside. So, with that in mind, we should be able to answer this question fairly easily. A is the number multiplying by the squared part, so A is negative 3. H is the number inside the parentheses being subtracted. This says x subtract 4. What did we subtract? 4. So H is 4. K is the number outside being added or subtracted, so K is negative 2. Now I'd like to present another way of solving this same problem, and then you get to choose which way you like best. The other way is to put the vertex form directly underneath your equation, and then line everything up algebraically. So, for example, we can see here that A is equal to negative 3. We can see that K is equal to negative 2. And we can see that negative h is equal to negative 4. So if we want to know what h is, we divide by negative 1 on both sides, and we get h equals 4. So a equals negative 3, h equals 4, k equals negative 2. All right, next equation. A, h, k. All right, a is the number multiplying by the squared part, so a is 999. H is the number being subtracted inside. Well, there is no subtraction inside, but we know that we can rewrite this as x subtract negative 1, and that these would be equal to each other because subtracting a negative is the same as adding. So now we can see that the number that we're subtracting inside is negative 1, because when we pronounce it out loud, we say x subtract negative 1. So what do we subtract? Negative 1. And then finally, the number added or subtracted outside is k, so k is 8. All right, and now let's solve this same problem using the alternate method that I said that I would be using as well. We place our vertex form equation directly beneath, and then we line everything up. So we can see that A is equal to 999. We can see that K is equal to positive 8. And we can see that negative h is equal to positive 1. Negative h is equal to positive 1. Divide by negative 1 on both sides, we get h equals negative 1. Same answers. A equals 999, h equals negative 1, k equals 8. Okay, great. 2 down, 4 to go. Next, g of x equals 7 plus the sum x plus 9 in parentheses squared. Okay, so when we solve a problem like this, the first thing that we want to recognize is the 7 being added is on the wrong side. Usually that would go at the end. But addition is commutative and can be done in any order. So that means that we can rewrite our equation to look like this: x plus 9 squared with the plus 7 at the far right-hand side. All right, so with that, let's identify a, h, and k. Here we go. A is the number multiplying by the squared part. Well, there is no number, which means we use the hidden number 1. For this problem, a is 1. Okay, h is the number inside the parentheses being subtracted. There is no subtraction, but x plus 9 is the same as x minus negative 9, x minus negative 9. So negative 9 is what we're subtracting. And k is the number added or subtracted outside, so k is 7. Okay, now using the alternate method of solving this problem, we place our vertex form directly beneath our equation. and then we compare by lining everything up. All right, so here we see that a is equal to 1. Here we see that k is equal to positive 7. And here we see that negative h is equal to positive 9. So divide by negative 1 on both sides, and we get h equals negative 9. And as you can see, we got the same answers using both methods. All right, next. F of x equals 9x squared minus 9. And this problem comes with a hint. The hint says to write x squared as x minus 0 squared. Okay, so before we use the hint, let's talk about why these are equal to each other. When you add or subtract 0, nothing changes value. I'll give you a very easy example. Today, I am 45 years old. If I add 0 to my age, I would still be 45 years old. If I subtract 0 from my age, I would still be 45 years old. So the same thing happens in algebra. Let's say you start with x and you subtract 0. Then what do you have? X. Nothing changed. And then when you square it, you would have x squared. So you can see that these are actually equal to each other. So what we're going to do in this problem is we're going to take this right here, that x squared, and we're going to replace it with this, x minus 0 squared. All right, so here's what our function will look like now. F of x equals 9, parenthesis, x minus 0, close parenthesis, squared, minus 9. And once we've written it in this form, it's very easy for us to see the values of a, h, and k. A is the number multiplying by the squared part, so that would be 9. H is the number inside the parentheses being subtracted, so that would be 0. X subtract 0. What did we subtract? 0. K is the number added or subtracted outside, so k is negative 9. All right, let's use the other method of finding a, h, and k. Okay, so we line up the pieces and parts compared to the vertex formula. So we see that a is equal to 9. We see that k is equal to negative 9. And we see that negative h is equal to negative 0. So negative h is equal to negative 0. Now there's no such thing as negative 0. Negative 0 would just be 0. So we get negative h equals 0. Divide by negative 1 on both sides, we get h equals 0. So you can see we get the same answer regardless of which method we use. All right, 4 down, 2 to go. Next, y equals negative, parenthesis, x minus 9, close parenthesis, squared. And the hint this time is to put a plus 0 at the end. All right, so let's do that. So y equals negative, parenthesis, x minus 9, close parenthesis, squared, plus 0. Now, why is it that we're able to put a plus 0 at the end of this? Well, because adding 0 doesn't change anything, for the same reason we talked about before. The reason the plus 0 is important is it helps us to find the value of k. All right, so let's do this. A, h, and k. A is the number multiplying by the squared part. Here's the squared part. There's the number multiplying by it. Remember, this hyphen is mathematical shorthand for negative 1 times. So a is negative 1. H is the number inside the parentheses being subtracted. This says x subtract 9. 9 is what we're subtracting. K is the number being added or subtracted outside, so k is 0. Okay, let's use the second method of doing this, which is to compare to our vertex formula. All right, so first we see that a is equal to negative 1. Next, we see that k is equal to 0. And lastly, we see that negative h is equal to negative 9. So we divide by negative 1 on both sides, and we get h equals 9. All right, last one. y equals 11x squared. Okay, we're going to use both of the previous hints in this one problem. We're going to write this as 11 parenthesis x minus 0 close parenthesis squared plus 0. So we can very easily see a, h, and k. All right, so we know a is the number multiplying by the squared part, so that would be 11. H is the number being subtracted inside, so that would be 0. K is the number added or subtracted outside, so that would also be 0. Using the alternate method of finding a, h, and k, we write our vertex form and we compare. So in this particular instance, we see that a equals 11. We see that k equals 0. And we see that negative h equals negative 0. Of course, there's no such thing as negative 0, so that's just negative h equals 0. Divide by negative 1 on both sides, and you get h equals 0. All right, there we go. 6 problems where we found a, h, and k. I know it seems like a lot of problems, but it's probably one of the most important skills in this entire section, and we need a lot of practice.